Welcome back to the course. This is Introduction to Azure Networking, and this is Lesson 2, where you'll deploy your second Azure virtual machine. By way of introduction, just a quick recap that links to the prerequisites for the course can be found in the Introduction section, and links to the deployment scripts, which are hosted on GitHub, can be found in the Resources section. In this lesson, we'll learn how to reuse, update, and remove resources from the deployment performed in the previous lesson, how to create a log analytics workspace and a storage account to use with network security group flow logging, how to associate a network security group to a subnet and how to enable flow logging, how to create application security groups and associate them to network interfaces, how to control internet access with application security groups, using them in security rules within network security groups, and how to create a second virtual machine attached to the existing subnet. We'll then connect to the virtual machine over the virtual network. We'll verify connectivity over the virtual network. We'll verify the outbound public IP address of the second virtual machine. And then we'll recap on the effective routes and effective security rules of the network interface. We'll then go into Network Watcher, where we'll learn how to use the packet capture and connection troubleshooting utilities. Let's review the topology diagram for this lesson. First, let's recap on the resources that we're reusing from the previous lesson. These include the resource group, the first virtual machine and its associated resources, and the virtual network and its existing subnet. Inside the resource group, we now also have a log analytics workspace and a storage account, which we'll use with network security group flow logging. We also have a network security group, which is now associated to the subnet instead of the network interface of the first virtual machine. We then have a second virtual machine with its operating system disk and its network interface, which is attached to the existing subnet within the virtual network. And now let's see what this looks like in the Azure portal once everything's been deployed. Here we are in the resource group view, and we can see a list of the resources that we've deployed. From the top, we have the application security groups. We can then see the log analytics workspace, the network security group, and the storage account. Next, we can see the first virtual machine and its associated resources. We can then see the second virtual machine, its operating system disk, and its network interface. And lastly, we can see the virtual network to which the network interface is connected. Now it's time for our demonstration, so let's get started. Here we are in Visual Studio Code. We have the deployment script open and our terminal is ready. Before executing the script, let's review it so we can understand what it's doing. From the top, we have our variables. Here we can see that we're reusing the resource group and location from the previous deployment. The log analytics workspace needs a name, a SKU, a quota, and a retention. And the storage account needs a name, a kind, and a SKU. Just a quick side note here, storage account names have strict naming standards and must be globally unique. If you're following along, I would recommend that you change the name to another string that is no greater than 23 characters in length and that comprises only of lowercase letters and numbers with no spaces or special characters. Again, we're reusing the virtual network and subnet from the previous deployment. The network security group, which will now be associated to the subnet, needs a name. The flow logs need a name, a version, a collection interval, and a retention. The application security groups, which we'll use to control outbound access to the internet, need names. The configuration of the first virtual machine will be updated. To do this, we need its name, along with the names of its network interface and network security group. We're deploying a second virtual machine, which requires a name, which we'll then use to standardize the names of its network interface and its operating system disk. And lastly, we're reusing the size, the operating system image, and the username and password from the previous deployment. Just a quick reminder here that it's not considered good practice to store passwords within scripts, and that this has been done here to keep things simple. Now we have our variables defined, we can start to include the resources in the deployment. First, we need a log analytics workspace. In addition to requiring a name, a resource group, and a location, this also requires a SKU, a quota, and a retention time. Next, we need a storage account. In addition to requiring a name, a resource group, and a location, this also requires a kind and a SKU. We're also taking the opportunity here to specify the minimum version of TLS that's used when accessing the account. We can then create the network security group for the subnet. This simply requires a name, a resource group, and a location. Next, we're enabling flow logging. This requires a name, a resource group, and a location, along with several other parameters. These include the network security group, the log analytics workspace and the storage account, the log version, collection interval, and the retention, and we're also enabling traffic analytics here. We can then create the application security groups, which we'll use to control outbound access to the internet. These simply require a name, a resource group, and a location. Since the network security group is now going to be associated to the subnet, before we can create a security rule to control inbound access to the first virtual machine, we need our current public IP address and the private IP address of the virtual machine. For our public IP address, we'll use the familiar invoke web request commandlet method from the previous lesson. And for the private IP address of the virtual machine, we'll query the network interface directly. Here we can show the network interface by specifying its name and resource group, along with a query for the private IP address of the first IP configuration. We can then specify the output to use a tab separated value, which we'll store in a variable, which we can then access later. We can now create the security rule to control inbound access to the first virtual machine. This requires the name and resource group of the network security group, along with several other parameters. These include the name, direction, and priority, whether the access is to be allowed or denied, the source and destination address prefixes, and the protocol and port. Next, we can create the security rule to restrict outbound access to the internet. As before, this requires the name and resource group of the network security group, along with several other parameters. These include the name, direction, priority, and whether the access is to be allowed or denied. And this time we specify the source application security groups and destination address prefixes, along with the protocol and port. Just a quick side note here, the IP address we've specified as the destination is the current address for the IP info API that we used in the previous lesson. Next, we can create the security rule to allow outbound access to the internet. As before, this requires the name and resource group of the network security group, along with a now familiar set of other parameters which include the name, direction, priority, and whether the access is to be allowed or denied, along with the source application security groups, destination address prefixes, and the protocol and port. Another quick side note here, in the destination address prefixes, we've specified internet, which is known as a service tag. This represents a group of IP address prefixes maintained by Azure, used to minimize complexity and security rules. Next, we can create the security rule to deny outbound access to the internet. As usual, this requires the name and resource group of the network security group, along with our familiar parameters. One last side note here, we're creating an explicit deny rule to override the default allow internet outbound rule, such that only the virtual machines associated to either of the application security groups we've created are permitted outbound access to the internet in accordance with the security rules we've defined. Next, we can update the subnet to associate the new network security group. This requires the name and resource group of the virtual network, along with the name of the subnet and the network security group. Then we can create the network interface for the second virtual machine. This requires a name, a resource group, and location, along with the virtual network and subnet name. We also associate the application security group here to allow outbound internet access. Next, we can create the second virtual machine. This requires a name, a resource group, and a location, but we also need to specify the size, the username and password, the operating system image, the name and performance tier of the disk, and the network interface. Next, we can update the network interface of the first virtual machine to associate the application security group to restrict outbound internet access. This requires the name and resource group of the network interface, along with the name of the IP configuration and the application security group. Next, we can update the network interface of the first virtual machine to disassociate the network security group. This requires the name and resource group of the network interface, along with the parameter to remove the network security group. Finally, we can delete the network security group that was previously associated to the network interface of the first virtual machine. This simply requires the name and resource group of the network security group. We can now execute the script, which will deploy the resources. Here we are again in Visual Studio Code, this time with our terminal window maximised. Just a quick reminder that when we're defining the virtual machine resource, we use the no-wait parameter, so the command will complete before the resource is in a succeeded state. This allows our deployment script to complete promptly, with the virtual machine continuing to provision in the background. Let's execute the script and observe the deployment. If you're following along, in a moment you may wish to pause the video until the deployment is complete on your side. Now our deployment is complete, let's change over to the Azure portal to review our resources. Here we are in the Azure portal, and this is the now familiar resource group view. We won't review the Log Analytics workspace and storage account in this lesson, as we'll cover this in more detail in the next lesson when reviewing flow logs and traffic analytics in Network Watcher. Let's recap on the virtual network. Under Settings, we can go into Subnets. Here we can see that the available IP addresses has reduced by 1 since we've added a second virtual machine, and we now have a network security group associated to the subnet. Let's go back to the resource group and look at the network security group. Under Settings, we can go to the inbound security rules. Here we can see the rule which allows inbound connectivity to the first virtual machine over the internet. Next, let's go to the outbound security rules. Here we can see the rules which restrict, allow, and deny outbound connectivity to the internet. Note that for the rules which restrict and allow access, we're now using an application security group as the source. Next, let's go into subnets. Here we can see that the network security group is associated to the subnet within the virtual network. Lastly, let's go into NSG flow logs. Here we can see that flow logs are enabled, that we're using version 2, that we're sending them to the storage account, and that they're retained for 30 days. We can also see that we have traffic analytics enabled, with a processing interval of 10 minutes, using the Log Analytics workspace. Let's go back to the resource group and look at the first virtual machine. We'll again copy the public IP address to our clipboard, as we'll need this in a moment to be able to connect to the virtual machine over the internet. Under Networking and then Application Security Groups, we can see that the virtual machine is now associated to the Application Security Group which restricts internet access. Let's go back to the resource group, and this time let's look at the second virtual machine. In the Overview section, under Essentials, we can see that the virtual machine is running, along with details of the operating system, the CPU and memory configuration, and which virtual network it's connected to. Note that the virtual machine does not have a public IP address associated to it. Under Properties, also note that we can see the private IP address of the virtual machine. We'll make a mental note of this, as we'll also need this in a moment to be able to connect to the virtual machine over the virtual network. Finally, under Networking and Application Security Groups, we can see that the virtual machine is associated to the Application Security Group, which allows internet access. Now that we've reviewed our resource deployment, let's switch back to Visual Studio Code and connect to the virtual machine. Here we are again, back in Visual Studio Code. From here, let's use the public IP address of the first virtual machine to connect over the internet using the secure shell. Now that we've connected to the virtual machine, let's validate connectivity over the virtual network. We'll again perform a DNS request as in the previous lesson, and we'll look up the Microsoft.com domain using the Google name servers. Here we can see that the request has failed. No responses have been received and the request has timed out. This is now expected behaviour as we've restricted outbound connectivity to the internet for this virtual machine. Next, let's perform a HTTP request and validate our public IP address in the process. We'll again use the same IP info API that we used in our deployment script. Here we can see that the request is completed successfully and that the IP info API has responded with the same public IP address that we used to connect to the virtual machine. This is now also expected behavior, as HTTP requests to the IP info API are included in the services which are permitted from this virtual machine. Next, let's validate connectivity to the second virtual machine. First, let's try to perform a ping. Here we can see that we've received a response to each of our requests. Next, let's try to connect to the virtual machine over the virtual network using the secure shell. Now that we're connected to the second virtual machine, let's validate connectivity over the virtual network. We'll again perform a DNS request, looking up the Microsoft.com domain using the Google name servers. Here we can see that the request is completed successfully and that Google's responded by providing both the IP version 4 and version 6 addresses for Microsoft.com. Now let's perform a HTTP request and validate our public IP address in the process. We'll use the same IP info API that we used in our deployment script. Here we can see that the request is completed successfully and the IP info API has responded with a different public IP address. Firstly, the DNS and HTTP requests both completed successfully, and this is also expected behavior since this virtual machine has unrestricted outbound access to the internet. Secondly, when a virtual machine isn't directly associated to a public IP address, Azure will randomly assign a temporary address for the purposes of outbound connectivity to the internet. We have no control over this address. It could be being used by several Azure customers and could be subject to change at any time. In future lessons, we'll introduce several methods to provide certainty on the public IP addresses used within our Azure deployments. Now that we've validated connectivity over the virtual network, let's change back to the Azure portal so that we can recap on the effective routes and effective security rules of the network interface. Here we are back in the Azure portal, in the resource group view. Let's go into the network interface of the second virtual machine and recap on the effective routes. Let's reorder the routes by address prefix. Recall that we have the 10.1/16 system route for the virtual network, and that we have the quad 0 system route for the internet. We also have the 10/8, 172.16/12, and 192.168/16 system routes for RFC 1918. The 100.64/10 system route is for RFC 6598. And the 127/8 system route is for RFC 5735. The remaining system routes are for address prefixes assigned to Microsoft and other organisations. Also, just a reminder that a non-route means that Azure will drop traffic to these destinations. Next, let's view the effective security rules. Here we can see a similar view of the security rules as to when we reviewed the network security group after the deployment completed. Next, let's switch over to the Network Watcher to demonstrate the packet capture and connection troubleshooting utilities. Here we are in Network Watcher. It can sometimes be useful to capture network packets, but you may not wish to install such utilities onto your virtual machines. Azure has the capability to capture network packets built into the platform. We'll select Packet Capture, and then we'll add New. The Azure portal has completed most of the fields for us. We'll accept the default capture location, which is using the storage account we deployed for the network security group flow logs, and we'll also accept the default number of bytes to ensure we capture the entire packet. We'll set a time limit of 600 seconds, and we'll leave the capture filter blank. To begin, let's start the packet capture. Now that the capture is running, let's generate some traffic. Here we are in Visual Studio Code, where we still have the session open to the second virtual machine. Let's rerun the last command, which will call the IP info API one more time. The command is completed successfully, so let's stop the capture. Here we are back in the Azure portal, where we can now stop the capture. Now that the capture has stopped, let's navigate to the storage account and download the capture file. Now that we have the capture file downloaded, We can open it with a utility of our choice. Here we'll use Wireshark. Now that we have the capture file open, let's identify the traffic we generated. First, let's apply a display filter for the initial DNS request. Next, let's choose the DNS response packet. We'll expand the response, then the answers, and finally, we'll copy the value of the address field. Next, let's apply a display filter for all traffic involving this address. Here we can see the setup of the TCP connection, immediately followed by the setup of the TLS connection. This is then followed by the encrypted application data. And finally, we can see that the TCP connection is closed and acknowledged by both parties. Next, let's learn how to use the connection troubleshooting utility. Here we are back in Network Watcher. In the previous lesson, we learned how to use the IP flow verify and next hop utilities, which showed us what the virtual network intended to do with a specified network flow. Here we'll use the connection troubleshooting utility instead, which can combine the capabilities of IP flow verify and next hop, but also expand upon them by generating traffic from the source to the destination and reporting on the outcome. First, we'll select the source virtual machine, then we'll select the destination virtual machine. For the preferred IP version, we'll select version 4. For the protocol, we'll leave the default TCP selected, and for the destination port, we'll enter the default port for SSH, which is 22. On this occasion, we can leave the source port blank. And for the diagnostic tests, we'll leave all of the default tests enabled. Finally, we can run the utility. Here we can see that the connectivity test has succeeded, that a number of probes have been sent from the source to the destination, there have been no errors reported, and the average latency is 1 millisecond. We can also see the results of the outbound and inbound NSG diagnostics, and that they indicate that the communication is allowed. We can also see the next hop is a default system route of type virtual network. And finally, we can see that the port scanner indicates that the destination port is accessible. That concludes this lesson. I hope to see you in the next one, where you'll learn how to add a second subnet and a third virtual machine to the virtual network you've already created. See you next time.